Hi everyone, in this video I will show you how to do the Holt-Winter exponential smoothing for the multiplicative. And my name is Lodemin. Here are my metric number and my teammates name and metric number. So first of all, we need to identify our data suitable or not to use the Holt-Winter exponential smoothing. And how do we identify it? First, we need to insert a line chart to show that if there is a seasonality or trend inside the data. Here, we can select the data from top to the bottom, and here we can use the X. Here are the X axis we use. Okay, so here we can see that there is a seasonal component in our data set. We can see that there is a for 1 year there is a season for 1 year, second year, third year. So now we put aside our graph first. So now we have identified that our data is suitable to use for the Holt-Winter exponential smoothing. Now we take a look on the formula that we need to use. So first is the level component LT, and here is the trend component, and this one is the seasonality component. And in the end, this one is the value that we want the most, which is the forecasting value. So from the forecasting value, the formula here, we can see that this formula require the level component and the trend component and also the seasonality component. So it means that before we get the forecasting value, we need to get these three values first. And now we take a look on the seasonality component. Here we can see that if you want to conduct a seasonality component, you need the previous seasonality component and also the level component. And here the trend component, if you want to conduct the trend component, you need a level component. So here is the level component here, but you can see that in the level component here, we still need the seasonality component and also the trend component. And don't forget that we have three parameters for this forecasting method, which is alpha, beta, and gamma. And basically the alpha, beta, and gamma is a constant. So when we take a look on all this formula, you see that there is not like having a root formula that you need to find us, right? But no worry, we will show it step by step. So first, we need to identify the initial value for the level component first. Now, we take a look on the formula for the initial value of the level component, which is the average value for the y value. And here you can see that there is a S symbol here. The S symbol means that the seasonality length, which means that from the from the graph, we can see that the one season is like about a year, which is for this data, for this example, is 12 month. So our S here is 12. So for the level component, we need to find the average value for the first season period of the value. Like here, the December here, we can go on the average, and for the first season period until the December here. So now this one is the initial value for our level component. So next we want to find the initial value for our trend component. Same, we goes back to the formula here, and we can see that this one is the formula for the initial value for our trend component. So it seems like you need to use this column, like the y value for the next season minus the y value for the current season. Here you can see that the next season, the January value minus the current season January value. Hit enter, and then just drag until the end of the first season here. So forget this trend component, you can use the total sum of these all component divided by the S, the seasonality length here, which is 12, and we need to square it here, because you see that the formula here, there's a double seasonality length. So here we need to square the value. Hit enter, and this is the initial value for our trend component. So next we need to find the initial value for seasonality component, which is here. How can we find the seasonality component? So here we can go back to the formula, and this is the initial value for the seasonality component, which is y divided by the initial value of the level component. So equal to y value divided by the initial value of level component. We will fix that, hit enter, and then we will find for the first period here. So there's a symbol here. Let me fix it. Here, just drag it. Okay, so this one is the seasonality component, and so for this is st minus s. The s is a seasonality length, which means that for here, this is the period 13, right? And our s is 12, so 13 minus 12 is 1. So this one will equal to the previous seasonality component. Same, you just drag for the whole season. Okay, so now we already have our initial value, and now is we need to get into using this formula to get into the to find our forecasting value. So same, we start from the level component here, which is equals to alpha, fix it, multiply the same period y value, which is this, and then divided by the st minus s, which is this, and plus open bracket 1 minus alpha, fix it, and then multiply by the summation of the previous level component plus the previous trend component, closing bracket, hit enter. So this is the formula for level component. Next is the trend component here. So same, we just key in all the formula, beta, fix, multiply by the level component for the current period minus the level component for the previous period. So plus 1 minus beta, and multiply by the previous trend component. So now we get our value for the trend component. And next is the seasonality component. So same usual, gamma, fix, multiply with the current y value, and divided with the current level component, plus 1 minus gamma, multiply by the st minus s, which is this one. So hit enter. So that is the seasonality component. And next, this one is for our forecasting value, which is the t plus m. The m is the how many steps forward you want to forecast. Like if you put a 1 here, t plus 1 here, and you will get use the previous level component here plus the previous trend component here, and then multiply by 1, closing bracket, and multiply by the s t plus m minus s. Actually this is the same for the seasonality component at here. So you just hit enter. So for this row of 5 elements, you can just drag it until the here. So we have done for the formula, and we get our forecasting value. So now here is our future value. this value we will base on the history data that we get all those forecasting value, and now we want to forecast the future value where this all the things is not happened yet, but we want to forecast it. Yeah, that's what we want. So now go back to the use. We want to use this formula here. I will paste it. Yeah, this one. I'll paste it here. So we need to find the s t minus s plus m. So actually this value is this one. You can just drag it of this value. Remember that this the seasonality component here, you just use the previous one here. So you can just put a value here, and here the formula got changed a bit, but actually it's the same, just the formula in the Excel got changed a bit. Here equals to the previous level component, open bracket, previous level component plus the previous trend component multiplied by the here, because this one is the first step, and next is second step, and next is the third step. So now we cannot like just now the formula above we put a 1 here. Now we need to put some logic here to make here we multiply by 1, and the next row we multiply by 2, and the next we multiply by 3. So here you can put the period here minus the period that you use all the value here, and fix it and multiply by this seasonality component. Hit enter, and then you can drag this value. So there is a problem here. Wait, let me fix it. Here you need to yeah, this one you need to fix it, and this one also you need to fix it. Okay, so hit enter, drag it, and that's all. Here you got a value, the forecast value for the future forecast value using the Holt-Winter method. And that's all, the how we build the template for the multiplicative Holt-Winter exponential smoothing.